Good evening, or actually good morning, because it's 20 past midnight. Yes, I know it's dark outside. So I had a good afternoon, and I kind of, wife had to go to bed early, she's up in the morning, so I thought, well, sod it, I'll go back in the garage. Finished off a second model of the infinitely irritable camber points at the front. The first model had originally a ordinary lock nut for the end of the joint here. As you can see, if I just pull it out from there, this is now an ordinary lock nut. I realised that the lock nut that was already on there, basically if you look at this one here, easy to explain. The thread obviously stops here. It's coming to the side. There we go. The thread stops there. And to give me the maximum amount of distance of this threaded rod into the long nut, which is this one, just actually this takes it completely apart and it'll become more apparent. Let's pull this one apart. There we go. Hopefully I'll explain a bit more. To give me the most amount of thread possible into this long nut at all times, basically I wanted to push this nut as far forward as possible. Now with a plain ordinary nut, it basically stopped when it got to that last thread, which was about, okay, I'll throw them before actually, which basically it would stop, should we say, there roughly where the last thread went out. Now I wanted enough thread in here, but I wanted to come completely over the top, and basically it gives me another 3 turns and it goes right over the top of this part of the joint with this end part of the joint here. Basically what I've done is the inside of this particular nut, I've chamfered it out. Now when I was looking at doing that, I realised there was an opportunity to actually make another nut, instead of having just an ordinary non-flanged nut. If I put a spigot on the nut, I could chamfer the other side. I could still have 10 millimeters of thread, albeit 6 would be on the spigot and 4 would be here. So I could actually make the nut 2 millimeters wider than the other one, because the other one was 8, have it further out, and also have less shear load put on the rod end. Because now, basically, instead of the nut, which would have been plain, and think that, if you can imagine where it's been inside here, the shear or the shear point would be along this edge here, because that's the point to where the nut would kind of trying to want to move. Okay, there's a little bit to the point there, but you're having to put the nut in tension to transfer it further out. Maybe doesn't sound too clear, but whatever. Either way, if you put a reduced spigot on here, basically the nut now takes quite a bit more shear load that way than previously mentioned. So now the shear load has a tendency of moving further out. Not that we have a problem, but for the sake of making a nut, instead of having the ordinary one, and since I've already got the miller set up to mill my hexes, it seems stupid not just to make another couple of those. So basically now we have our tube that I shall weld into the wishbone, our long nut at the back which threads onto it, and then our lock nut at the front, like so. And there's the 3 pieces. So now we're cooking on gas, as they say. There's the 3 of those. Getting carried away on the lathe, as you do, instead of pulling out some equipment that I needed to get my tube bender out, I'm making a noise this afternoon. I decided it was time that maybe I should start making the middle pivot roller bearing version of the inboard rocker for the front. So basically she's going to sit between here and here. So if I can, one of these is, look, they are a pretty good fit. Hang on a second, just pull one of these out. Easier said than done. There you go. Right. So basically, less loads to worry about than the rear. It's quite simple in comparison to the rear. The rear has to deal with this push rod here changing angle as the rear upright changes. Honestly, let's just show you. If I can, I've collapsed it like there. The rear has a angle change, so there is more of a load this way on this particular house. The shock absorber I can keep in one plane, and that's not a problem. This angle here, the center point there, is exactly the same plane, so that doesn't move. But this push rod definitely moves the axis slightly. So this here has two taper roller bearings to take that bending moment out. The front, a lot easier. The push rod, I can keep everything in a dead straight line, from the push rod point on the wishbone all the way up to the rocker, down from the rocker down to the thing, is all going to be exactly in line. So it don't have to worry too much about loads going sideways. So I can have more of a roller bearing than a tapered roller or a needle roller kind of version. So now these are nice and simple. Basically, turn that down, used half the bearing that's going to be inside here, and the other half of the bearing will stick out. And then I shall machine the same 2024 here, and that's 6¼ inch thick, so that's 6.35 wide. Do the same kind of profile from the rear, and basically that'll transfer the load directly into the bearing, not necessarily directly into this. So the bearing itself will take the majority of the load. This would obviously be drilled and screwed into there, and the other side, the other one will be done the same. 5 bolts offset, so technically there'll be 10 holes machined in this, but 5 screws from one side, 5 screws from the other side. That's how I did the rear, basically. So that's the front. So now I've turned the two center spaces, which is probably the most awkward part. The bore of this is 3/4 inch. So tomorrow I'll turn a piece of 1 inch bar, which is roughly the outside edge of this. Don't want to go any further than the outside edge. Don't want to interfere with the seal. Even though the seal is reduced, it's handy to have the shaft. Probably have no more than 2mm spacer here, but I'll turn it down so it's 3/4 inch. So it'll go all the way through that. So it'll go from 1 inch turned down all the way through at 3/4 inch. 1/2 inch hole if it's bum, as they say, and then normal 1/2 inch bolt at the back of that. So and then put a spacer on this side, so basically we have spacers either side that it saves that particular bearing face just running kind of flat against the surface. It'll actually have a 2mm gap from there. It'll give it a bit of room. So there we have it. I shall, before I go to bed, I shall do the cam profile of the front rocker arms, the actual main profile piece that sits on here. And then I shall machine them out tomorrow. We could laser cut them, but you know what the hell, at this point I'm just going to machine them out. It's a 1/2 inch bit, but it's nice and easy. And then obviously the precision hole in the plate as well to match the bearing, so basically it's a nice snug fit on here. So I'll do the same, nice snug fit on that, fits on here, nice and simple. Holes drilled out for that, drill through, Bob's your uncle, so I should have the rockers pretty close hopefully tomorrow. That's about it for the moment. So good morning, 1:30, there we go. Speak to you soon.